Right, hi there, welcome to the sixth and final video of the integration topic at higher. Today we're going to look at the area between curves, okay, so not specifically between the curve and the x-axis like last time. Four things we're able to do here, quite similar to last time. Be able to identify and find the limits that bound the desired area, set up a definite integral to evaluate the area, evaluate the integral to obtain all the value of the area, and give your answer in context, ensuring separate integrals used were necessary. So in fact it's exactly the same, there's just one thing we need to be aware of here. Okay, now if I look at this example, if these are our limits here for this area that we're looking for above, okay, so if we're looking for that area that I've shaded in just there, the limits are going to be either side of this there. Now, firstly, those limits are going to be, unless otherwise, they're going to be points of intersection. So we're going to find those limits if they're not given by simultaneous equations. The second thing to note is if I take, ignoring the blue curve just now, if I take the red curve all the way down, and what I'm going to do is going to change my colour here. If I change it to, I'll just go to blue, okay. If I integrate between those limits for just the top curve, I get the area all the way down to the x-axis. Okay, so I get the area all the way down there. Now, I don't really want all the way down there for the start of this question. What I want is I only want the top area. Okay, I only want the area in there. Okay, down to that second curve. So that area is going to be given by integrating and using the top area all the way down to the x-axis, but by removing, okay, and I'm going to use green here, sorry, that's quite difficult to show without being able to point at it, without this area at the bottom. Okay, so I want the whole area underneath that curve down to the x-axis, but without that green area at the bottom. Okay, now just going to take some of that away so you can show that again. So you want that whole area between the top curve and the x-axis, but without that area in there. Okay, or more accurately from that line right to this line over here. Okay, so you're going to set up the integral between your limits, but you're going to do the upper curve take away the lower curve, because you don't want all the way to the x-axis, you only want from the top curve down to the bottom curve. Okay, so to look at a couple of examples to try and clear that up. Here, to find the shaded area, I need to do the integral between the 2 points there and there, the two limits, but with the upper curve take away the lower curve. So I want to integrate from limit a to b with upper take away the lower with respect to x in this case. Okay, now it's going to be a bit of work here. Okay, this might end up being quite a long video. Okay, but let's start off. So firstly, we don't know what these limits are. Okay, so we have to find them. Now, those limits are your points of intersection between these curves. So to find the limits, and again, give yourself a wee signpost. To find the limits, we're going to do simultaneous equations. Okay, which we do by making them equal to each other. So it's going to be 6 minus 3x squared equals to minus 3 minus 2x squared. Okay, and then that's 9 is equal to x squared, which means x is equal to plus or minus 3. Not interested in the y coordinates, it's going along the way that I want my limits. So that's going to be minus 3 to 3. Okay, so that's part 1. And then I need to set up my integral. Okay, so now I'm going to find my area. Okay, I'm going to find the area that's shaded there. So the integral needs to be from the limits, which is minus 3 to 3, of the upper curve, the upper bound of the area, which is that curve going up there, which is going to be your 6 minus 3x squared. So it's 6 minus 3x squared. Take away your lower curve, which is minus 3 minus 2x squared. Now be very careful here. You need to take away all of that lower curve. Okay, and all of that is being integrated with respect to x. Okay, so I'm going to move on to the next page. Going back to this one here. In fact, I'll just go back here and sneak it at the bottom. That becomes between minus 3 and 3. 6 take away 3x squared plus 3 plus 2x squared with respect to x. And that will tidy up to 9 minus x squared. So to find this area, we know the integral is going to be 9 minus x squared with respect to x between the limits of minus 3 and 3. Okay, so sorry that last slide is probably a bit messy. We found the limits, we did the upper curve take away the lower curve, and this is the integral that will give us the area. So integrating that will be 9x minus x cubed over 3 between 3 and minus 3, and then substituting the limits in, it'll be 9 times 3 minus 3 cubed over 3 for your first limit going in, take away 9 times minus 3, subtract minus 3 cubed over 3 for your second limit. Okay, so that's 27, take away 27 over 3, which is 9, so that'll be 18. So the first bracket, take away negative 27, add 27 over 3, which is add 9, so negative 27 add 9 is negative 18. Okay, so that means the area there is 36 units squared. Okay, so going back again, find the limits if need be. In this case, it'll be points of intersection, so simultaneous equations. You then set up your integral by using those limits, doing your upper curve, take away your lower curve, evaluate that integral, and it will give you the area. Okay, second example, looking at two curves here now. Similar to the last video, this is a bit tricky because halfway through, when x is 2, the upper curve changes. Okay, now similar to the x-axis, that would make your area negative. So to find this area, you need to do two separate integrals. Okay, let's call it area 1 on the left and area 2 on the right. Okay, so for area 1, the integral is going to be between minus 1 and 2. The upper curve is your f of x there, which is x cubed minus 7x squared plus 8x plus 16. And then you take away your lower curve, which is your line g of x in this case, which is 4x plus 4. Okay, and all of that is integrated with respect to x. Okay, so tidying that up, it's going to be between minus 1 and 2. Your x cubed is going to just be x cubed. Minus 7x squared is going to be 7x squared. 8x later on you're taking away 4x, so that'll be plus 4x. 16 later on you're taking away 4, so it'll be plus 12. All of that integrated with respect to x will give you that left hand area. Okay, I'm going to shift over here a wee second. So integrating that means it's going to be x to the power 4 over 4 minus 7x cubed over 3 plus 4x squared over 2, which is 2x squared, plus 12x between those limits 2 and minus 1, which, so you do, that becomes 2 to the power 4 over 4 minus 7 2's cubed over 3 plus 2 times 2 squared plus 12 2's. Take away the same thing there but for minus 1. So that should be a minus there. 7 times minus 1 cubed over 3 plus 2 times minus 1 squared plus 12 times minus 1. Okay, and that gives you a value for that left hand area. Okay, give me 2 seconds, I'm just going to run that through. Okay, that works out to be, I'll just come over here, 99 over 4 units squared. Okay, it's definitely worth acknowledging. Okay, this is very tricky using the tablet to write on this, and it does look very messy. I'm hoping you're following it okay. This is a nightmare for us guys to mark because there's a lot of places to make mistakes, there's lots of calculations, and there's lots of follow-through marks essentially from mistakes, but that makes it a good question for you guys to do, because if you're talking about a 5-6 mark question, you should be able to pick up 4, 5, 6 marks. Yes, it might be ugly, like it is, and it might take a lot of work and it might be quite cumbersome, but go through it, make sure you got all the marks and try and be as clear as you possible. Try and be a lot tidier than I am being here, essentially. Okay, now that gives you area 1. Okay, area 2 is the same thing, but with the roles reversed in terms of the upper minus lower. The line is now on top here. Okay, that is the upper bounded area, whereas the curve is on the bottom. So area 2 will be very similar, but the other way round. Okay, so area 2, okay, maybe I should have made that a bit bigger, is the integral this time between 2 and 6, where the upper bound is the line, so 4x plus 4. Subtract all of the curve, which is x cubed minus 7x squared plus 8x plus 16. Okay, now going through that again, you would tidy it up, integrate. I'm just going to pause the video. I don't want you watching all this mess. I'm just going to do it as neat as I can and get to the next step. So give me a wee second. Okay, so apologies for that. I've just skipped all the way through. So that's 160 over 3 units squared for that. Okay, so take a wee second if you want, pause the video and have a look through. Again, I'll try to make it as neat as possible, but not done very well. Okay, upper minus lower changes, tidies up, integrate, sublimits, and then calculate. Okay, which means your total area there. Okay, which you need to finish out. Total area is your 160 over 3 from that second area. Add your first area, which was 99 over 4. Okay, so it gives you 937 over 12 units squared. Okay, so pretty messy there. So you can see how it is easy to make mistakes and to lose marks, but we can still get lots of marks for setting up the integral properly, integrating properly, substituting in limits, and so on and so forth. They're quite nice questions to pick up marks on. Okay, so 4 things you should be able to do: being able to identify and find the limits that bound the desired area using simultaneous equations if necessary, being able to set up that definite integral, evaluate it, and then give your answer in context, making sure we use separate integrals if it needs to be. Okay, so apologies again for the kind of mess around that video, but I'm hoping you're picking up the kind of the gist of it. Okay, thank you.